Alright, welcome to our 7th video of Unit 7. We're going to start finally talking about full electron configuration. When determining an atom's electron config, we always got to make sure to place every electron that's actually in the atom. So you can't leave any out, you got to make sure you place all of them. So there have been many times where you really just want to place the first 5 or 6 because, the rest of the 50 or so get really kind of tedious. Well, anyways, we got to make sure also to only place 2 electrons per orbital. We have to fill orbitals with the lowest energy first. And we have to make sure to only put electrons in an orbital so that their energy levels can actually hold. Now, it's really not all that big of a task, but we do got to actually satisfy all the rules and principles that there are for electron configurations. So, the following chart helps us determine what order electrons are to be placed in what orbitals. You'll notice there's no chart, because I'm going to actually kind of walk you through it. Well, actually, first I'm going to show you what it looks like, and then I'm going to walk you through it. And I recommend, if this is an issue, you watch and then practice. You don't kind of write as I write something. You just literally watch me do it. First off, here's the chart. Now, this chart's really easy to make, but it looks a little confusing at first. How you read it, though, is by following these arrows. So the very first arrow goes through the 1s orbital. Second one goes through the 2s. Again, if you're writing, don't worry about writing this down now. I'm going to walk you through how to write it. You just got to make sure you know what to do with it now. But first, then we go through 2p and then 3s, 3p and then 4s, and then 3d. A lot of people start reading the chart like this. They'll read it left to right. That's wrong. That's not how this is meant to go. It basically ends up kind of shortcutting you into the exceptions to energy levels, because notice we go from 4s to 3d. We don't go 4s to 4p because 3d is requires a little bit less energy than 4p. Anyways, we keep following this, and that gets us our paths. So let me now show you how to write it. First off, write 1s all the way down to 7s. Then write 2p all the way down to 7p. Then 3d all the way down to 7d. And 4f all the way down. Alright, so here's actually where the arrows kind of get a little bit confusing, but not too much. First one goes through 1s, and basically each of them are going to be diagonal to the one above it. The third one gets a little harder, but not really. 2p, then 3s, and then right below it, 3 to 4. Then we go 3, 4, 5, 4, 5, 6, 4, 5, 6, 7, 5, 6, 7, 6, 7, 7. That's our chart. So, if used properly, this shows us that our first 3 orbitals are 1s, 2s, 2p, 3s, 3d, 4s, wow, sorry, I lied, 3p, then 4s, 3d, 4p, etc. So, there you go. Alright, so for a full electron configuration, we're going to use the following steps. First off, you need to determine how many total electrons that you need to be placed. Now, most of the time, this is just the atomic number. However, you're going to also have to factor in charges. So, if there's a negative charge, that means you add some electrons. Or if there's a positive charge, you get rid of some electrons. Figure out how many total you need to place. Second, you start placing electrons in the 1s orbital, meaning that's basically our starting place. And we're going to keep going up the chart, or down the chart, until we run out of electrons. More specifically, you place electrons until all are placed, even if this results in a degenerate or unfilled orbital. So we max out electrons because, remember, we know how many each can hold, until we're done. So I'm going to let you practice this and actually go and try the next example if you want. I'll walk you through this one and I'll show you how to do the last one. Alright, welcome back. So selenium, which is Se, has a total of 34 electrons. So we start at 1s. S orbitals can hold, S orbitals, there's one of them that appears, so we have a total of 2 electrons that can go in there. And that basically says we place 2 of these 34 electrons, and I like to keep a tally below it that shows we have 32 left. Okay? After 1s comes 2s, and we can hold a total of 2 there. That gets us to 30. And basically, we keep going until we eventually get to 0. Now, the last one may be filled, it may not, but everything before the last one will be filled. So, you'll see. Then we go 2p. We have 3p orbitals for a total of 6 electrons. We don't need to specify which p orbitals are in, but we'll do that a little bit later. For the full electron, you don't have to. Then we have 3s, which can hold 2. We have 3p, which can hold 6. 4s, which can hold 2. 3d, which can hold 10. And 4p, which can hold 6, but we only have 4. So we're going to put 4p4, and that gets us to 0. And that whole thing is your answer. There you go. Okay. Hopefully you had time to try this one with the last one. But if not, take some time to try it, and then I'm just going to basically show you the answer. Alright. Hopefully you tried it. Well, here's the answer. So, really, really, really long answer, and I know that's, you normally won't have to go that long. Key thing you got to realize is that if you end up in 7s2, you probably got it right. Just letting you know. That's the easiest way to check these things. And you'll get to the point where you'll have an idea of why it's 7s2 if you don't already. But that's radium. That's full electron configuration. Thanks for watching.